Good morning, grade nines. Good morning, everyone. I hope everyone had a great weekend. I'm back again today, and I am still what you call your host, Kolisani Mbata, and those are still my social media handles. You can actually continue the conversation after class on those Twitter handle and Instagram handle. Um, uh, as I've said, I hope you had a great weekend. Let's see what we're going to learn today. So today we are going to learn more about parallel circuits and how to connect resistors in parallel circuit. And we're also going to focus in the lighting system in a house. Remember that last week on Thursday and Friday, we were looking at the series the series circuits, if I remember very well. As usual, I always give you a homework. So right now, by now what I need from any one of you. You know by now what I need from any one of you to get our homework started now. Do I have anyone to assist me with our homework corrections? Unkabeti came in early today. Yes, Unkabeti, let's work. Good morning, Unkabeti.
Morning, sir.
How are you,
I'm
Unkabeti?
good, and you, sir?
You know why? So I'm very well, thank you so much. Yesterday I gave you a homework. On Friday I gave you a homework, and then here you were just supposed to put in a correct answer. So we said to you, complete the following statement. If you increase the resistance in a series circuit, what happens?
The current decreases.
Yes, current decreases. Current, agreed, current decreases. Then what happens if you what SI unit do we use for electrical current? So electrical current is measured in what?
Amps.
Amperes. Yes, in an ampere. Yebo. Correct. We measure them in amperes. Amperes. Yay. Forgive my ghetto pronunciation. Amperes there.
Yes, sir.
Electrical power is expressed in what?
I'm not sure, but I think watts.
It is indeed expressed in watts. So you know the kilowatts there in your heater. When you're checking there, you will see that it is expressed in kilowatts and something. A light bulb with a resistance of 2 ohms is connected to a 4-volt battery, right? Then they want to know what is the current flowing through the circuit.
So to be honest, I didn't do that one because I don't understand.
So let us go back there. Where am I? We're here. They say to you, complete the following statements. Okay, a light bulb with a resistance of 2 ohms, is connected to a 4-volt battery. Then can I give you the choices that you can choose from? You can
Yes,
choose
sir.
a light bulb with a resistance of 2 ohms is connected to a 4-volt battery. What is the current flowing through the circuit? Is it 0.5 amperes, 5 amperes, 2 amperes, or 1 ampere?
2 amperes.
2 amperes. Thank you very much. I'm not going to do anyone homework here. So everyone is going to answer. So the answer is 2 amperes. So we can write 2A or 2 amperes, but I prefer you write 2A only because the marker will know that you are talking about amperes. Then the last one is AMRA. AMRA creates a circuit with 12 volts battery. it is a parallel circuit with 3 branches, and each branch has a 3 ohm resistor. How much voltage drop at each resistor on the circuit? Unkabetsi?
Sir, I'm still calculating.
Okay. Can I give you the choices?
Yes.
A, A 4 volts, B 12 volts, C 36 volts, or D none of the above.
None of the above.
Why?
So aren't you supposed to plus 12 plus 3 plus 3? I think you need to add 12 plus 3 plus 3. I think, I'm not sure.
No. The battery is giving us 4 volts. 12 volts, I'm sorry. And then it is in a parallel circuit, and with 3 branches, each branch has 3 ohm resistor. So that means now we know that the current is shared equally within the parallel circuit. I know that we haven't done it. So the correct answer there, it will be 4 volts. So it's going to be 4, 8, 12. The energy from the battery will be utilized equally. Remember that, okay, no, I haven't taught you this one, but the correct answer there is going to be 4 volts. Are we clear?
Yes, sir.
So today we are dealing with this one. I knew that most of you would not get this one, since last week we did not actually do what you call the parallel circuits. But today we are doing parallel circuits. Thank you so much, Unkabetsi. Actually, my mom was asking what happened to you. Because you're always the first one to say yes, sir, yes, sir. But last week we missed you. But thank you so much for showing up today. Let us continue. Thank you so much.
Yes, sir.
Who is going to assist me with the quiz corrections? Who is going to assist me with the Benny? Benny, open your mic, Benny.
Morning,
Benny,
sir.
how are you, Benny?
I'm fine, and you, sir?
I'm good. We are here with a quiz. You know, quiz, you get one answer wrong, you're out. I'm kidding. I'm kidding. So what do we call a one path for current to flow?
A series circuit.
Series circuit. Thank you very much. Correct. Series circuit. What is polarity?
When atoms bond with each other and when the atoms come together, they share electrons.
But in this physics part, what do we call it?
I don't know the name, sir, but
So we're talking about the negative and the positive.
positive
Yes.
Yeah.
Yes, that's the correct one. The polarity of the cell here.
Yes, sir.
But you were right in the chemistry terms. The current flow.
Oh, sir, I didn't do that one, sir. I skipped that.
This one is almost the same with that one. It's from negative to positive.
Positive. Okay.
The current flows from negative to positive, Benny. Then what the advantages of series circuit?
They don't overheat easily.
Series circuit.
Yes, sir. Oh, oops.
So
I think someone else should answer this, sir, because I think most of my answers will
let's
be
move.
wrong.
And then examples of series circuit?
Is it
Components.
series circuits a component, sir? A battery?
The components, yes. We're gonna go back to that one. Anyone with an answer for number 4 must get ready. So I want you to assist me with number 5, examples of series components.
So is it a battery?
Yes, a cell.
Open switch.
A switch. It
Close
can be
switch.
Yes, switches. I would write switches there.
Light bulb.
A bulb. Yes.
A resistor.
Resistor. Yes.
Is there one more?
Yes.
A buzzer.
Oh yeah.
A buzzer.
A buzzer, I can put it in there, but and then the other one, guys, how do we get this
Wires.
Wire. Wire, sir.
wire? What do we call
Wires.
wires? What do we call wires in natural
Conducting
science?
wires.
What do we call wires in science?
Conducting. Wait.
Conducting wires.
Conducting wires. Yeah.
Conductors. Thank you very much.
Oh no way.
How can you forget conductors, guys?
Sorry.
All of you forgot conducting wires or conductors. And then disadvantages of series circuit.
If one of the components are not working, then the whole circuit is broken.
Yes, that's very much correct. We can phrase it as an open will interrupt current flow to all devices. So an open switch will actually will interrupt. Am I correct? Interrupt flow, current flow to all other devices, So if we have a problem with the first bulb there, that means the current can no longer flow to other sides of the circuit. So that's the one disadvantage of this one. And if there's a resistor there, also affects the entire circuit. So that's why I'm just going to put it like this. And then what are the series rules? We all know it.
I didn't do that one, so.
Series rule. Okay, thank you so much, Benny. Let me find someone who's going to answer number 4 and number 7 for Benny.
Yes, sir.
We are doing it for Benny, guys. Anyone who wants to assist Benny there? Grade 9s, come on. So you all didn't answer number 4 and number 5 and number 7.
Yeah.
Sir, can I please try number 7?
All right, let's start with number 4.
I'm trying.
Number 4. I have number 4.
Okay, answer number 4.
Okay. So the first advantage is that all circuit components are controlled by one switch.
Yeah, control the amount of current flow. Yes, control the amount of current flow. And the other one?
They're less likely to overheat.
Why? Because now remember that if there's too much current from the cell in the first battery or in the first bulb there, yes, in the first bulb, I'm sorry, then if the damage is there, remember that now it will overheat, and then the other ones, yes, will not overheat because they will be affected. Remember when you're looking at the disadvantages. So I would say 1, they control the amount of current flow, and 2, they divide the total voltage. Ne? That's the second one. Divide the total voltage. Who has number 7 for us?
Me, sir.
Okay, let's do number 7. Series rule.
The total resistance of a series circuit is equal to the sum of individual resistance.
How do you represent that? Very much correct. I love it. But how do we? I've given you a clue on the screen. Check the screen.
R1 plus R2 plus R3.
Plus R2 plus R3. And then the last one?
Voltage applied to a series circuit is equal to the sum of the individual voltage drops.
How do we represent that? V
plus is equals to V1 plus V2 plus V3.
Thank you.
And if the circuit is broken at any point, no current will flow.
Yeah,
I think that's a disadvantage also.
Yes, that's the disadvantage. V3. We are done with our homework. Any questions concerning our homework?
No, sir.
Thank
No,
you very
sir.
much. Let us continue to today. Please listen attentively because it is very, very important.
Yes. No, sir.
Yes. Before I actually introduce you to parallel circuits, let me actually now let us actually all of us recap the series circuit. We said when cells are connected together in series, the total voltage is the sum of the voltage of the individual cells. The total voltage across the battery is the same as the sum of the voltage across each of the resistors connected in series circuits. That's a rule. That's a rule. We've just discussed it now. Then they say to you a resistor with a higher resistance will have a higher voltage across it. A resistor with lower resistance will have a lower voltage across it as well. We're still continuing with our series circuit, grade 9. The current is the same when measured at any point in series circuit. Then the total current decreases with each resistor added in series to the circuit. The resistor now. Remember that we did say that the resistor is the component that decreases the flow of current. Is the form of component that decreases the flow of current in a circuit. And then we said in a series circuit, then if the resistance is higher, and then the flow of resistor, the flow of current is decreasing or decreases. And then let us continue, grade 9s. And then we can now look at parallel circuits because we understand series circuits. We now can look at parallel circuit. What exactly is the difference between a parallel circuit and a series circuit? We say connecting cells in parallel. We connect cells in parallel by connecting all negative terminals together and all the positive terminals together. When cells of the same voltage are connected in parallel, the voltage of the battery is the same as for one cell only. Are we clear? As for one cell only. Remember, but that we said the cells are always connected we said the cells are always connected in series, grade 9. So that statement, the first one, we say we connect, when we're saying connect cells in parallel, we connect cells in parallel by connecting all the negative terminals together. Remember that if it's a negative to a negative, it won't have any effect. I even made an example with your remote control batteries. If the negative touches to another negative, that means there won't be any flow of current. So that means when we cannot connect cells in parallel for a circuit, because now that means the circuit won't have any current to use. I hope you are aware of that, grade 9. Let me show you this. There we go. We have a parallel circuits here. These are examples of parallel circuits. Let us look where my cursor is there. You can see this line where the conductors the battery, this is a cell, right? We remember you said the longer one is the positive and the shorter one is the negative. Therefore, that means the energy here, the current is flowing to your right, but this is a switch. Therefore, if the switch is open like this, that means this one here, ampere here, this is the ampere one, so the bulb here will not have any electricity. Therefore, it applies to every other cell. Are we clear? But if we close this switch here, I will show you just now with another example. But I was explaining to you this line, the conductors here with the cells, and the one here with the resistor and the bulb, and this one, you can see that they are parallel to each other. Going back to your mathematics, what do we know about parallel lines? We know that they are lines that will never ever meet. So same here, this is parallel. Look at this one again. If you're looking at resistor 1, resistor 2, and resistor 3 here, you will see that they are also parallel to each other. Therefore, we say this is a parallel circuit. Are we clear? Grade 9. So if we also look at which other, looking at this one here, You see this circuit here where my cursor is. This is a series circuit. This is a series circuit. And obviously you can see that we have how many cells here? We have 2 cells. We have 2 cells. If you're looking at this cell, and then you also come here, you'll see here we have 1 cell. This is how we represent 1 cell. And then when you come here, this is how we represent 2 cells. And then we can also see this one. You've got 1 cell here. Here you've got 2 cells as well. I hope everyone is clear as to how we are representing the circuit cell. If they say to you, draw a parallel cell with, let's say, 3 resistors, you will draw something like this. And then they will tell you how many cells do we have. So we see here, they also just told us that we have a 12 voltage battery here. They didn't tell us how many cells do we have. But now I'm sure as a grade 9 learner, you can see the difference between a parallel cell and a cell connected in series. Let us continue. Connecting more cells in parallel does not increase the voltage of the battery. So if you're connecting cells in parallel, the voltage will remain the same. I'm sorry. Connecting the cells in parallel, the voltage in the battery will remain the same. It does, however, make the battery last long because the current will not be flowing through. Remember, I explained to you that now there won't be any energy flowing through if the batteries are connected in parallel. We said, how do you connect cells in parallel when negative is next to negative? Remember that the golden rule of the circuits is that the cells need to be connected in parallel, in series. However, the different components in the cell can be connected in parallel or in series, but the batteries or the cells, they always need to be in series, grade 9s. Then when we're talking about a parallel circuit, we talk about an electrical circuit where electrical components are connected next to each other, provides more than one pathway for the current to flow through. Remember, in series circuit, we've got only one pathway. Here we have more than one. We have more than one pathway. But for in series circuit, we have only one pathway. Here in parallel circuit, we have more than one pathway for the current to flow through. Are we clear, grade 9s? Thank you so much. But then what can we say again about the parallel circuit is that when we connect the negative terminal of 2 or more cells together and the positive terminal of the same cells together, we say that cells are connected in parallel. I've actually said that. Therefore, the voltage of a parallel battery is the same voltage as the voltage of each cell. We know now what we're talking about here. We are aware. Then let's continue, grade 9s. An electric cell is a system. An electric cell is a system which a chemical reaction causes the flow of electricity through an external circuit. Remember, we spoke of the external circuit and the internal circuit last week. Then now remember that when we're talking about electrical cell being a chemical reaction, we said, remember we discussed that chemical reaction obviously continues to react until it gives us electrical reaction. The chemical reaction give us electrical reaction, and then once we get electrical reaction, that will be current flowing through your conductors, going to your bulb or wherever it's needed. Last week we did we did different types of elements and different types of output from chemical to electrical reaction, and then we can get heat or light or whatever that the output might be. And then we say a battery consists of 2 or more cells connected together. We said a cell, it's one, and then once we have more cells together, we say we have a battery. That's why we said a car battery has more cells connected together. let us actually recap that an electric cell is a system with a chemical of, we've done that one. And then let us look at this grade 9. How do you draw a labeled circuit diagram of 3 cells in parallel connected to a voltmeter? Draw a labeled circuit diagram of 3 cells in parallel connected to a voltmeter. Can you do that? I am sure everybody can do that because I've shown you. So as we had R1, R2, R3, we can actually take out those resistors and put bulb 1, bulb 2, and bulb 3. But remember that we use the mathematics rule about about parallel lines. We know that parallel lines are lines that will never meet from mathematics classroom. And then I want you to look at the grade 9. Resistance. So we spoke of resistors. We all know now what are resistors. So we said the resistors are components in a circuit that reduces the flow of actually current. So they say resistors are part of the electronic circuit found in most electrical devices. Resistors restrict the flow of current in electrical circuit. These components may have a high resistance, which lowers the flow of current. Then, when connecting resistors in parallel, we need to we connect them next to each other. We do not connect them in series in parallel, but we connect them next to each other. We connect them next to each other so that electric charges can pass through any one of the resistors. A circuit where there is more than one pathway for the current to flow through is called a parallel circuit. So now they are called parallel circuit because they've got more than one pathway. So this also highlights or actually makes you to remember that in series circuits, we only have one pathway. We only have one pathway for current to flow through. So that means it actually limits the circuit. Look at this. Voltage in parallel circuit. In a parallel circuit, we can measure the voltage over each resistor, but also over all the resistors together. We also going to look at the parallel circuit rule when it comes to voltage. Remember, we said with the series circuit, the rule there is V is equals to V1 plus V2 plus V3. When we're looking at the series circuit rule again, when you're talking about resistors, we say a total resistance is equals to R1 plus R2 plus R3. We want to see now, is it the same now with the parallel circuits, grade 9? I want you to look at this. So let us look at the circuit. Which cell components can you label there? Which cell components can you label in this circuit? It's a parallel circuit. I want you to label the circuits that you can count. Which one? So we've got resistor 1, then resistor 2, and resistor 3. We've got conductors and we have cells. And you can also see that we've got more than one pathway for current to actually flow through. If we can open a switch anywhere there, that it does not mean we won't have a current flowing through to other parts of the cell. Are we clear, grade 9, on that one? Then I'm hoping everybody is still following. Let's take a serious look at this comparison. If you've got a cell phone with you there, you can take a picture of this, or you can also get the slides immediately after the class. They are already uploaded on our trainer page, www.africateamgeeks.co.za, and then you click on the Natural Sciences grade 9, you'll get these slides. And then let us look at the series and the parallel circuit. You see how it looks. With the series circuit, you can see the voltage there. You can see how R1 and R2 are positioned. But again, when you go into the parallel circuit here now, you'll see that actually in the parallel circuit, we have these parallel conductors with the components. That means the components are not in series, but they are parallel to each other. As for resistor 1, resistor 2, and resistor 3, they are parallel to each other, while they are in a sequence for a series circuit. They are in series. They are following each other. You see resistor 1 there, resistor 2 there. They are following each other. The voltage then is in series and is in series. That's why we said in series circuit, if we experience any problem with R1 here, therefore R2 will not get current. But where these ones are different, if R1 has a problem, it does not mean R2 will not light or R3 will not light. And then they say current always remains in same in series, but in parallel, current is dividing. So the current in parallel circuits divides. The voltage now in what you call in series. Oh, I moved my thing down. The voltage in series, what happens is it divides, but in parallel remains in series. Is that true? We'll need to check this one and see. But when we look at equivalent of resistance, we said the total resistance is equals to R1 plus R2 plus R3. But here, the total resistance is always 1 over R2 plus 1 over R2. So we divide here, is what we said there about the current now. It will divide. I hope you are aware of this. And then I want us to continue grade 9s to say that you understand. Then current in parallel circuits. In parallel circuits, the electric current splits. That's why we said they've got more than one pathway for current to flow. So in parallel circuit, the current splits. It splits. That's why it goes to different angles. That's why I made an example yesterday on Friday. I'm sorry. I said on Friday to you, the house, your houses are connected in parallel. Why am I saying that? I said because if you switch on the switch in the kitchen, the light, it doesn't mean the one in the bedroom will automatically switch on as well. You have connected them in a parallel way. Therefore, it doesn't mean that one switch connects every other room. That's why the light in your bedroom might be off, but people who are still sitting in the sitting room, with their lights on as well. Manga, your hand is raised.
Sir, I have a question, sir. Sir, some houses have main switches, sir. Like, how does that happen that they have a main switch and then they have a switch for that room? Like, in some houses, you can switch on all lights from one switch. If
So
you understand
now
what I'm saying.
I hear
So how
you.
does that happen, sir? Like,
So
is there one part that is connected or
okay, Manga,
something like
let me
that?
explain to you. When you're talking about one switch connecting the whole house, I'm hoping you are not talking about main switch, the one that is in the box there. Remember that your box there will be working as your cell. So now your cell, it doesn't mean that because your light is off, it does not get current. That's why if the main switch will be working as the battery in the house. The box, I think all the houses have the main the switch king. Yeah, the one that I'm looking at my house, it's written switch king. That's where the power of the house is installed. That's where the volts is there, like the kilowatts and everything. Then you've got the main switch. The main switch will obviously be allowing current to actually flow to different parts of the house. But if you're saying you've got one switch that actually turns the whole house on, and when you're turning it off, that means your house is connected in an incorrect manner, because now that means it is in series. That means if one bulb is not working, the entire house bulbs will not work. But for you to have your own switch in the bedroom, and there's a switch for your mom's bedroom and the kitchen switch and so on and so forth, it means your house is connected in parallel, because you can actually control the switch for each room. But when you're talking about a main switch, you are talking about the power supplier of the house. So it's not that. It's different from when you're talking about the connection. We're talking about how the house current is actually distributed. If you can control in one room and not automatically all the rooms, that means your house is connected in parallel, and that's how it should be. Then grade 9s, I don't have much of a homework today, but it will be wrong of me not to give you a homework. Here is our homework, grade 9. You will actually define each of the following terms. I want you to define what is a voltage, what is resistance, what is electric current, what is series circuit, what is a parallel circuit, what is an ammeter, and what is a voltmeter. That's your homework for today, grade 9s. What is a voltage? What is resistance? What is electrical current? You're defining them, series circuit, and finally you will actually define ammeter and voltmeter. That's what I want you to actually do. Voltage, resistance, electric current, and series circuit, parallel circuit, ammeter, and voltmeter. Grade 9, we still have more of your resources when you follow that link there. And grade 9 again.
So can you please go back?
Go back. Okay, I'm here. And then I want actually to continue the conversation with our social media pages. You know, by now, you need to go www.africateamgeek.co.za, and I will definitely be back tomorrow with more concerning our series circuit. Tomorrow we would look at actually we would be looking at the rules of the circuit, and also we want to now start calculating. We need to start calculating the resistance in series, the resistance in parallel, because we now know the rules when we're talking about electricity. So tomorrow we will be doing the following: the lighting system in a house. How do you can actually calculate how did they reach that this month you owe 58 rands or you owe 1,250 rand. You will also actually do the importance of accurate resistance in parallel circuits. You'll also learn about safety with electricity and the national electricity grid. That's what I was talking about. You will know exactly how is City Power and Eskom charge us. You will know that tomorrow. Without any waste of time, grade 9s, please have yourself a great day, and then I will see you tomorrow. We'll talk actually tomorrow. If you still have other
Where can I
bye
get the
everyone. Bye everyone.
Bye, sir.
So where
Bye,
can
sir.
I subscribe?
Bye.
Bye, sir.
Bye. Thank you, Tanya.